At the end of today's lesson, we talked about the fact that ethanol could be produced by this process called fermentation using glucose. So I'm going to ask you to go through these particular calculations that are involved in this chemical reaction so that next lesson, when you set up your investigations, that we can just go through a few different variety of questions that might be involved when we're talking about fermentation. So if we have a look at the conditions of fermentation of glucose, I'll leave you to continue doing that for homework together with your plan for the investigation. But if we look at the equation together, we can see that glucose, C6H12O6, will react to form 2 moles of ethanol in an aqueous state. So that might give you a clue as to the condition of glucose, as well as 2 moles of carbon dioxide gas. So if we had to think about the particular question, how will you know that the reaction is occurring? We're going to just have a look at the states of the various substances that we've got here. So glucose, we've got ethanol aqueous, and we've got carbon dioxide gas. Now we know that when we've got a gas, if we don't close the container or contain whatever's reacting, we may actually have some of that gas escape into the environment. So that's what we're going to be looking for. So where's the gas going to go? Hopefully it's released into the atmosphere. That then helps us when we're calculating the reaction progress. So we know if we can keep an eye on, for the few days that we're conducting this experiment, if 13.5 grams of carbon dioxide is lost for the duration of that time, then we might be able to calculate the mass of ethanol that was produced by this reaction. So first thing we'd do is write the reaction. We're going to go through the steps first before we do it together. Then the second step we might take would be to calculate the number of moles of the substance being given, in this particular instance, carbon dioxide. Then we'd use the molar ratio and we'd plug it into our chemical equation. And then we calculate the number of moles of the substance that we need to calculate, which in this case is ethanol. And then we calculate its mass. So let's have a look at doing that particular question together on a piece of paper. So we've got 13.5 grams of carbon dioxide. So our first step was to write the chemical equation. So I'll write it again on paper. C6H12O6 reacts to form ethanol and carbon dioxide. So we know this is aqueous and we know this is gas. If we've got 13.5 grams of carbon dioxide, I'm going to place this underneath the carbon dioxide in the equation, and what I want to do is calculate the number of moles. So we know moles is equal to mass over molar mass, amongst other equations. So we'd go 13.5 divided by 12.01, refer to your periodic table for this, plus 16 by 2. So if I do that on the calculator now, then our answer should come out as 0.306748 ... moles. Okay, and we obviously save this in our calculator because we don't round until the end. Then we have a look at our carbon dioxide to ethanol ratio. We know that's 2 to 2, so therefore that becomes a 1-to-1 ratio. So therefore the number of moles of ethanol in this particular equation, or in this particular example, is exactly the same as the carbon dioxide. But I need to write this molar ratio in so that when I see your work and you're working out, I actually know where you got this value from. Okay, we just don't go straight from here, where the moles of carbon dioxide is shown, to this value here. You've got to show the working. How did you work out that particular number of moles? Once we've done that, we then have the moles of ethanol, and we can just use that and plug it straight into our mass equation, which is mass is equal to number of moles times molar mass, which is then equal to 0.30678 dot dot dot, whatever the value was, I maintained that in my calculator, times 12.01 times 2 plus 1.008 molar mass of hydrogen, times that by 6 plus 16, which is equal to, because I've kept that in my calculator from before, times that by 46.068. You guys use your periodic tables, obviously, and our value should be 14.1312 dot 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 grams. Now if I go back to my question, of course I look for the number of significant figures that was given. In this particular instance, 13.5 is 3 significant figures. So I look at my answer and I say 14.1 rounded off in grams to 3 sig fig. And that's how we would calculate the mass of ethanol from that particular mass of carbon dioxide given off. Let's have a look at another example. If 25 grams of glucose is reacted and it reacts to completion, so all of it reacts to form carbon dioxide and ethanol, it's asking us to calculate the mass of ethanol produced. So let's have a go at doing that one together. So we said we had 25.0 grams of glucose and we want to work out ethanol produced. Same thing, we'd write our chemical equation, C6H12O6, just waiting for it to clear up, there we go, becomes C2H5OH plus CO2, 2 moles of each. So if our mass is equal to 25 of glucose, that was what was reacted, I then work out the number of moles, which is mass over molar mass, which is equal to 25.0 and 12.01 times 6 plus 1.008 times 12 plus 16 times 6. It's not going to hurt you to actually write that out in a response, because it just tells me that exactly how you've gone to work out the molar mass of this particular substance. So 25.0 divided by 12.01 times 6 plus 1.008 times 12 plus 16 times 6 is equal to 0.1387 dot 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 moles. Okay, once again, I then use my molar ratio. So in this particular instance, it's glucose to ethanol. And that, in this particular instance, is a 1:2 ratio. So the number of moles of ethanol, therefore, is going to be equal to this value here, 1.1387 times by 2. So we'll do that in our calculator. Times 2, which is equal to 0.277 dot 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 moles. Once we've done that, we can then calculate the mass of the mass of ethanol, which is number of moles times molar mass. Make sure you show you working. 0.277 dot dot dot, keep it in our calculator, times 46.068. This is our molar mass of ethanol from our prior working. So make sure you keep that value in your calculator, 46.068, which is equal to 12.785 dot 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 grams. Once again, it was 3 significant figures. So if I then round this up, I've got 12.8 grams of ethanol, mass of ethanol. Okay, so make sure you know how to do those examples, and we'll go through a few different questions using this same sort of strategy in class next lesson.